In the early decades of the 20th century, the world hummed with excitement. Radio had transformed human life almost overnight. News traveled instantly, families gathered around wooden receivers to hear music drifting through the air, and vast networks of communication linked cities, ships, and nations. It felt like the world had finally broken free from silence. Yet beneath this wonder, a stubborn problem persisted like a splinter the industry could not ignore. No matter how advanced the equipment, no matter how carefully tuned the frequencies, there was always a faint, irritating hiss hiding in the background. It crackled over conversations, fluttered over music, and crept into long-distance transmissions. This static seemed to appear out of nowhere, interfering without mercy. Engineers blamed everything from lightning to poor insulation, but no one truly knew the source. And in a world becoming increasingly dependent on radio, an unanswered mystery was unacceptable. Bell Telephone Laboratories, the most advanced center of communication research, could not afford guesswork. Their global radio links had to be reliable, especially as the world grew more interconnected by the day. Every unexplained noise in a transmission meant financial losses, weakened signals, and frustrated customers. The managers at Bell Labs gathered reports, charts, and theories from countless experts, yet all they had were opinions, not solutions. The static didn't behave like ordinary interference. It came and went on its own rhythm, refusing to follow weather patterns or mechanical cycles. It was a ghost in the wires, haunting every system. Bell Labs' leadership knew the mystery had to be solved, and quickly. They needed someone patient, methodical, and capable of untangling this invisible knot, someone who would listen, observe, and follow the faintest clues. That responsibility landed on the desk of a young engineer named Karl Guthe Jansky. Karl was not the type who fought for recognition. He did not crave the spotlight or boast about his talents. Instead, he carried a quiet confidence, a belief that problems deserved patience, that mysteries deserved curiosity, and that answers could be found if one simply kept listening. When he was handed the assignment to track the source of the static, many saw it as a small, even dull task. But Karl saw something different. He saw a puzzle waiting to be solved. He had always been drawn to challenges hiding in plain sight, and this one intrigued him. Where others heard noise, he heard possibility. With calm determination, he began sketching designs for a device capable of capturing and measuring radio signals more precisely than ever before. There was nothing glamorous about the project, yet Karl approached it with the seriousness of a man searching for truth. His colleagues chuckled at his enthusiasm, but he continued working undisturbed. He sensed the mystery held a story that deserved to be uncovered. Karl built a massive rotating antenna that slowly swept across the sky, listening to everything the air could offer. He analyzed thunderstorms, electrical machinery, automobile noise, and countless other sources. He catalogued every crackle and hum, eliminating one possibility after another. Yet one strange hiss refused to disappear. It came with a pattern unlike anything on Earth, shifting not with the 24-hour rotation of the planet, but with the movement of the stars themselves. As Karl studied this rhythm, a breathtaking realization took shape. The static wasn't coming from weather, machines, or any human-made source. It was coming from the center of the Milky Way galaxy. In one astonishing moment, Karl Jansky became the first human being to detect radio waves from outer space. He had not been searching for galaxies, nor trying to rewrite astronomy. He was simply trying to solve a technical inconvenience. But this inconvenience became a scientific revolution. His discovery cracked open a new field, radio astronomy, and gave humanity a new way to observe the cosmos. The faint hiss he had chased with patience and curiosity turned out to be the whisper of the universe itself. What began as an overlooked assignment had transformed into one of the most significant scientific breakthroughs of the century. Karl Jansky's quiet persistence had achieved something extraordinary. He had helped the world hear the galaxy for the very first time. Karl Guthe Jansky grew up in an environment where curiosity was not just encouraged, it was a way of life. Born in 1905 in Norman, Oklahoma, his household was filled with the quiet hum of intellect. His father, a respected professor of physics, filled their home with books, instruments, and conversations that sparked wonder in young minds. Karl was never the loudest child, nor the most demanding. Instead, he observed everything. He loved tinkering with toys that made noise, pulling apart gadgets to see how they worked, and building small contraptions that impressed no one but fascinated him deeply. While other children chased games in the street, Karl chased the invisible forces, signals, and the unseen mechanics behind everyday life. His father noticed this gentle spark and nurtured it, teaching him early lessons in discipline, logic, and the beauty of scientific thinking. By the time Karl was a teenager, he wasn't just curious, he carried the mindset of a budding scientist. Karl eventually enrolled at the University of Wisconsin, where his father had become a well-known figure. Though some might crumble under the pressure of living in a brilliant parent's shadow, Karl remained steady. He was not driven by competition or fame, he simply wanted to understand the world. At the university, he studied physics and engineering, fields that fed his fascination with radio waves, electrical currents, and the delicate behavior of signals. He wasn't the type to dominate classroom debates or seek the approval of professors with bold claims. Instead, he built his academic identity on patience and precision. Professors admired his quiet commitment. He worked long hours in labs, often staying after others left, adjusting circuits, taking measurements, and recording results with careful detail. Karl didn't chase breakthroughs, he chased accuracy. And although he didn't yet know it, these habits were shaping him into the one person capable of hearing a whisper the entire scientific world had overlooked. Karl carried into adulthood the same calm, thoughtful temperament he had shown as a child. He was not a man of big opinions or dramatic gestures. Instead, he listened, truly listened, not only to people, but to problems, patterns, and the smallest inconsistencies in the world around him. This made him a remarkable engineer, but also a deeply dependable human being. When he joined Bell Telephone Laboratories, he was surrounded by some of the brightest technical minds in America. Yet, unlike others building grand theories or pushing boundaries at breakneck speed, Karl found comfort in meticulous work. His colleagues liked him for his kindness, his humility, and the quiet certainty he carried into every task. He wasn't the type to argue loudly in meetings or insist on attention. And still, everyone trusted him, because when Karl worked on something, it was done with sincerity and accuracy. He had ambition, yes, but of a different kind. He didn't seek to be first, he sought to be correct. He didn't pursue fame, he pursued understanding. That mindset would one day guide him toward a discovery he never intended to make, yet was destined for. Behind Karl's professional calm was a warm personal life that balanced his quiet intensity. He married a woman who appreciated his soft-spoken nature and supported his long hours of experimentation and research. Their partnership was built on understanding rather than grand displays, and their home became a shelter of peace where Karl could rest, think, and recharge. His family grounded him, giving him joy beyond his scientific pursuits. Evenings spent with his wife, simple conversations, and gentle laughter offered a comforting rhythm that kept him steady. When he became a father, that warmth deepened further. Despite his demanding work at Bell Labs, Karl made time for his children, encouraging curiosity in them just as his father had encouraged him. He was the kind of parent who explained how radios worked instead of simply handing them over, who answered questions patiently, and who believed every child carried a spark of discovery. His household was filled not with intensity, but with lightness and learning. This balance between the engineer and the family man was the quiet strength behind his career. It was his personal life that gave him patience, his upbringing that gave him discipline, and his gentle nature that allowed him to see significance where others saw only static. All these pieces of Karl's life, childhood curiosity, disciplined education, humble ambition, and a warm family foundation, came together to shape the man who would one day tune into the universe without even meaning to. His journey toward discovery had not yet begun, but everything about his life had prepared him for it. And soon, the universe would call to him in a whisper he alone could recognize. When Karl Guthe Jansky stepped into Bell Telephone Laboratories, he entered a world where innovation pulsed through every hallway. Bell Labs was the beating heart of communication research, home to brilliant thinkers, experimental ideas, and technologies shaping the future. Karl arrived not as a star scientist, but as a young engineer eager to contribute. His supervisors quickly noticed his patience, precision, and almost meditative attention to detail. And so, when the persistent problem of radio static threatened long-distance communication, they turned to Karl, not because the task was glamorous, but because it required someone who would not rush to assumptions. He was assigned to investigate the mysterious interference on shortwave radio signals. Many saw it as a minor technical job, but Karl, as always, approached it like a puzzle waiting to be solved. Unbeknownst to anyone, this small assignment would guide him toward one of the biggest discoveries of the century. Karl's first step was designing an instrument capable of listening to the sky. What he built looked nothing like traditional equipment. It was enormous, stretching nearly 100 feet across, mounted on old car wheels, and engineered to rotate full circle so it could scan the horizon from every angle. Co-workers laughed and nicknamed it Jansky's merry-go-round. But Karl was not bothered. He knew the design served a purpose no one yet understood. The antenna could detect even the faintest traces of radio signals, and Karl tuned every wire, every coil, and every connector with obsessive care. Day after day, he adjusted its sensitivity. Night after night, he tested its rotation. He felt like an astronomer aiming a new kind of telescope, one that did not see light, but listened to the invisible. And soon, the antenna would begin whispering secrets to him, one faint crackle at a time. Once the antenna came to life, Karl devoted himself to studying its recordings. His routine became a cycle of listening, noting, eliminating, and listening again. He identified the static created by thunderstorms. He measured the hum of passing automobiles. He catalogued every noise generated by wires, switches, generators, and atmospheric conditions. Piece by piece, he cleared away the known sources. Yet one signal refused to fit any earthly explanation. It was faint but persistent, repeating on a schedule that made no sense, not the 24-hour clock of Earth, but a slightly shorter rhythm. Intrigued, Karl plotted its behavior across days, weeks, months. He realized the timing matched something extraordinary: the sidereal day, the rotation of Earth relative to the stars, not the sun. That meant the signal did not move with the planet's daily cycle, it moved with the cosmos. Karl's heart raced as he connected the dots. This static was not man-made, not atmospheric, not mechanical, it was celestial. With every new measurement, the truth grew impossible to ignore. The signal peaked whenever Karl's antenna pointed toward the same region in the sky, specifically the heart of the Milky Way galaxy. The hiss that engineers had complained about for years was not an error at all. It was the galaxy speaking. When Karl finally announced his conclusions, the scientific world reacted with astonishment. He had discovered the first radio waves ever detected from outer space, a phenomenon no one had even imagined listening for. In one quiet, breathtaking moment, Karl Jansky opened a new window on the universe and accidentally founded radio astronomy. His discovery proved that the sky was not silent. Stars, nebulae, and galactic centers were sending out signals all along, signals Earth had never heard until Karl built an antenna big enough, sensitive enough, and guided by a mind patient enough to find them. What began as a company assignment became a revolution in human understanding. Astronomers now had a new tool, a new frequency, a new way to read the universe's secrets. And though Karl did not set out to make history, his persistence, humility, and relentless curiosity carried him into scientific immortality. The man who was told to solve a nuisance ended up giving humanity an entirely new sense: the ability to hear the cosmos. For most of human history, the universe appeared silent. People looked at the stars and believed that beyond the shimmering lights, there was only emptiness. But Karl Jansky's discovery proved the opposite. The cosmos was alive with sound, sound we could not hear with our ears, but with instruments designed to listen beyond human limits. Radio waves are a form of electromagnetic radiation, just like visible light, but with wavelengths far longer and gentler. They drift across space without effort, slipping around obstacles and passing through cosmic dust that blocks ordinary telescopes. These waves carry stories: the birth of stars, the collapse of giants, the restless motion of galaxies. The universe speaks constantly, and radio waves are one of its oldest, most universal languages. When Jansky tuned his antenna toward the sky, he wasn't listening to noise. He was hearing a message billions of years old. Every radio wave begins with movement. When charged particles, like electrons, accelerate, they create ripples in the electromagnetic field, the same way a stone creates ripples on a pond. In space, there are countless events powerful enough to stir these particles violently. Massive stars spin with magnetic fury. Nebulae glow with energetic clouds of ions. Black holes twist space around them like whirlpools. Supernova explosions send shockwaves through galaxies. Each of these cosmic events produces its own signature of radio waves. Some are loud, some are faint, some are steady, and some flicker like distant heartbeats. These signals travel for thousands, millions, even billions of years before reaching Earth. And though they weaken with distance, they never fully die. That is why Karl's antenna, sitting quietly in a New Jersey field, was able to detect a whisper that had traveled across the Milky Way. The universe is vast, but radio waves connect it like threads of invisible light. Ordinary telescopes rely on visible light, but visible light tells only half the story. Space is filled with dust clouds that block starlight, hiding enormous regions of the universe from optical observation. Radio waves, however, are long and flexible. They pass through dust, fog, and debris as if they were not there. This makes radio astronomy a powerful tool, one capable of revealing the hidden skeleton of the cosmos. Where optical images show darkness, radio images reveal structure. Where starlight fades, radio waves continue their journey undisturbed. Through radio technology, scientists can map the shape of galaxies, detect signals from pulsars, measure the rotation of black holes, and even observe the faint echo of the Big Bang. Karl's discovery gave humanity not just a new tool, but a new sense. Like developing hearing after a lifetime of silence, radio astronomy unlocked parts of the universe previously invisible. Suddenly, scientists weren't just seeing the sky, they were listening to it. Karl Jansky never intended to revolutionize astronomy, yet his work laid the foundation for everything that followed. His rotating antenna, mocked as a merry-go-round, became the blueprint for a new generation of radio telescopes. After his discovery, massive structures began rising across the world. Dishes spanning hundreds of feet, arrays stretching across deserts, observatories capable of capturing the faintest cosmic whispers. Every one of them owes its existence to the moment Jansky realized the static followed the stars. His work proved that the universe communicates, and we can decode its messages with the right tools. Today, radio astronomers study quasars, pulsars, galactic jets, and cosmic background radiation, phenomena Karl could never have imagined. Yet every discovery traces its origins back to that quiet engineer listening patiently in a field, studying a noise no one else cared enough to understand. Jansky showed that even the faintest signal can change the world. His legacy is not just scientific, it is philosophical. He taught humanity that the universe is speaking, and that curiosity, patience, and humility are sometimes